Let's work on question 4 in this video. So we have to compute the improper integrals. Okay, so what do we have in part A? This is the integral that we have. Let's just understand why is it improper. Because you see, we don't have this infinity thing like we had in the previous video, because we saw that when we have infinity in the boundaries, we had to substitute with the value so that we can integrate it. Well, the same concept applies here, except that it's a bit different, meaning that if we look at the boundaries, remember the boundaries are values that we have to substitute into x, the area between those values for x. If we substitute this value into the x over here, well, we'll have a division by 0, right? We would have 1 minus 1, and division by 0 is undefined, meaning that the upper boundary must approach 1 but must not touch it. And what is something that approaches a value? That's a limit. So we're going to replace that upper boundary with the limit of a value, let's call that value a, approaching 1. Where is it approaching from? Well, it's approaching from the negative side, because it's coming from the value of minus 1. So on the x-axis, it's coming from minus 1 until 1, from the negative side, from the left side. Hope this makes sense. So from the negative side over here, and let's write this entire thing. Let's write this entire thing as a first step. We have 2x squared plus 4x minus 6 divided by x minus 1, and all of this dx. Now, what do we do next? Well, we have to solve this. Yeah, by the way, this is an integral. We have to solve this integral, right? This is minus 1, and this is a. Now, how can we solve this integral? We would like to make it more simple, because if this is a division, this is a fraction, then we can probably divide it. But let's see how we can do so. First of all, to make it more simple, let's see if we have a common factor over here, because we have many terms. 2, 4, and 6. Well, the common factor is 2. Let's just solve this separately. If we take 2 as a common factor, we're left with x squared plus 2x from the second term minus 3 from the last term. Okay. With that said, what can we do next? We could solve this expression. If we substitute here, not substitute, but we just give values x. What is a number that when we multiply we get minus 3, but when we add we get positive 2? Well, if we say 3 and minus 1, 3 times minus 1 is gonna be minus 3, 3 minus 1 is gonna be positive 2. So this works, meaning that this expression can be written as x plus 3 times x minus 1, and now we multiply all of it with 2. So we multiply all of it with 2 like that. Now, with that said, we can open the brackets. Let's open the brackets with the first term. We will have 2x plus 2 times 3 is plus 6, and then we multiply with the other one times x minus 1. Okay, we got that. Now we can substitute it into our integral. Let's see what we get. We have it over here. We have it the limit of a approaching 1 from the negative side. What do we have in the integral? Well, we will have 2x plus 6 multiplied with x minus 1 divided by x minus 1, and the integral is between the value of minus 1 and a, and we also must keep the dx. What can we do now? We can simplify it. X minus 1 with x minus 1 goes away, and what are we left with? We will have the limit of a approaching 1 from the negative side, and over here we will have the integral between, let me just change colors for that, we will have the integral between minus 1 and a of 2x plus 6 times dx. Now we can integrate, term by term. So what's that going to be? We will have the limit of a approaching 1 from the negative side, and we integrate 2x times dx. We keep the boundaries from minus 1 to a. The integral of 2x dx, that's just 2 times x to the power of 1 plus 1 is 2, divided by 1 plus 1, which is also 2, plus the integral of 6 times dx, that's just 6x. We keep that in a bracket. Now we can cancel out some stuff. 2 and 2 go away. What are we left with? Let's write it over here below. We're left with the limit of a approaching 1 from the negative side, and in brackets we're left with the expression of x squared plus 6x, and the boundaries for that are going to be between minus 1 and a. So minus 1 and a. Now we can substitute the values. So let's do it one by one. We're going to substitute a into the expression first. So if a goes over here, what do we have? Let's go over here below. Let me just zoom out to get some more space, because it feels very tense like that. So we have a to the power of 2 plus 6 times a. We close that bracket. minus, and we're going to substitute -1 into there as well. Let me change colors for that. We're going different color, this one. We're going to put -1 over here, so we have -1 to the power of 2 plus -1 times 6. 6 times -1. Close that bracket, and we also have to keep the limit. We have to still keep the limit. The limit of a approaching 1 from the negative side of all this thing. Now, what do we get as a result? Let's see. We will have over here the following: the limit of a approaching 1 from the negative side, a approaching 1 from the negative side, and in brackets we're left with a squared plus 6a, a squared plus 6a minus, and what do we have over here? We have -1 to the power of 2, that's just 1. 6 times -1 is -6, so that's equal to -5. -5 becomes +5, so we have +5 over there. Now we can substitute the value for our limit, so 1 is going to go into a, and we're going to have 1 squared plus 6 times 1 plus 5. What do we approach? 1 plus 6 is 7, 7 plus 5 is going to be 12. So that limit converges to the value of 12. Hope this makes sense. In the next video we go, actually I wanted to say that integral approaches the value of 12. In the next video we go to part B.